At the end of the last video, we introduced the periodic table and had a look at the differences that exist in the elements across the table. In particular, we looked at the groups which run up and down the periodic table and the periods which run across the periodic table. Now, looking at this version of the periodic table, you can see that their metals are by far the largest group, the yellow group. Non-metals, the blue group, exist on the right-hand side over here, and metalloids straddle the two in a diagonal line and are represented here in green. In this video, we're going to have a closer look at each of these subgroups of the periodic table. Let's take a look at the largest group on the periodic table, and that is of the metals. Metals have several features in common. However, it should be noted from the beginning that different metals have different strengths in regards to these properties. Most metals are solid at room temperature, the exception being mercury, which is a liquid. Metals can be polished to produce a high shine or luster, and we see that in jewellery. They are good conductors of electricity and heat. We know this from electrical wires being made of metal. They can all be beaten or bent into various shapes. We say they are malleable. Again, this is another aspect of metals that lends themselves to jewellery. They can be made into a wire. We say they are ductile. They can be stretched out into a wire. And they usually melt at a high temperature. Mercury is another exception to this. It melts at -40 degrees centigrade. The next largest group in the periodic table is made up of the non-metals. Only 22 of the elements are non-metals. At room temperature, 11 of them are gases, 10 are solid, and 1 itself is a liquid. The solid non-metals have most of the following features in common. They cannot be polished to give a shine like metals. They are usually dull or glassy. They are brittle, which means they shatter when they're hit. They cannot be bent into shape. They are usually poor conductors of electricity and heat, and they usually melt at low temperatures. Many of the non-metals are gases at room temperature. All of these factors should be taken into consideration when comparing metals to non-metals and noticing the similarities, if any, and differences between them. This last selection of elements in the periodic table are called the metalloids. Some of the elements in the non-metal group look like metals. The example we're going to use here is silicon. Silicon can be polished like a metal, but it's a poor conductor of heat and electricity and cannot be bent or made into a wire. It's not malleable or ductile. Elements that have some features of both metals and non-metals are called metalloids. There are 8 metalloids altogether: boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. Before completing this video, let's quickly go back and have a look at the uses for metals based upon their properties. Copper is ductile and conducts electricity well, hence it's used in electrical wiring. Remember, ductile means the ability to be stretched into a wire. Iron is strong and malleable, that means it can be beaten into shape, and is perfect for large construction. When combined with other metal and non-metal elements, which is commonly called an alloy, iron becomes steel. The luster and malleability of metals has seen their use in many forms of jewellery for many thousands of years. Non-metals also have extensive use. Carbon, particularly in its solid form and when exposed to extreme pressure, creates diamond. Carbon is incredibly strong in its crystalline structure because of the way that the carbon atoms align themselves. Neon gas is inert, so it doesn't react with much, if anything. It glows red-orange in the vacuum discharge tube, creating the ubiquitous neon signs that we see around the town. Silicon is used in integrated circuits because of its low conductivity to electricity and heat. These properties have enabled modern computers to exist in the size and the power that we see today.